So 6.4 notes, we're going to cover transformations of exponential and log functions. Now, luckily, the transformations for exponential and logs are going to follow a lot of the same rules that we've done for our other transformations. There is going to be one big difference. Whenever we're working with exponential or log functions, we will need to create a specific parent. The base is what is going to determine your parent function. So, for example, here we're going to create a parent function with a base of 2. So if your function, for example, had a different base, like a base of 3, you would have to create a different parent function. So let's go ahead and create our parent functions for base 2, log base 2, and base e. So reminder, negative exponent can move the 2 to the denominator, so it's 1 over 2 squared, or 1/4, or a quarter. Now for these, when you're plugging in values, I expect a lot of people can do these in your head. It's always okay to use a calculator. I like to use Desmos. So we can see 2 to the minus 2, 2 to the minus 1, 2 to the 1, 0, and 2. All right, so let's plot the points. And we want to make sure we get a nice curve. Now you notice when we are making a parent function for logarithms, we want to start with y values, plug those in to find the x. Now there is another way to do that, and it's related to changing from log to exponential. So for example, if I plug in y, say minus 2 is equal to log base 2 of x, you can change that to exponential form. So base to a power, so 2 to the negative 2 is equal to x. But we can see we already did this. 2 to the negative 2 was here. So 1/4 or a quarter. What I want you to notice is this and this are related. And they're related because if we change this to logarithmic form, we get this. Or we can say this is the inverse. This is another way you can find your parent function when you have a logarithm. You can change it to an exponential, find the parent for the exponential, and then just flip the values to get your parent for your log. But again, we can also find it by plugging in the y values. All right, let's plot our points. So a quarter minus 2. And again, we want to make sure we get a nice curve. Now, whenever we're making a parent function with a base of e, we always want to write down an approximation. I would suggest starting with the exact and then using a calculator or Desmos, get the approximation. So for example, e to the minus 2, and then e to the minus 1, e to the 0, e to the first, e to the second. So e to the negative 2, and I'm going to go ahead and round my values. Then e to the negative first. Remember, anything to the 0 is 1. Then e to the first and e squared. Just going to put those values in my table. So I'm going to round them to the nearest tenth. So when you're putting in values such as 0.1, just want to estimate. You can just say that at negative 2 or at 0.1, it's really close to 0. And then negative 1, we're at 0.4, that's close to a half. 0, 1, 1, and 2.7, a little more than a half. And then at 2, we're at 7.4, close to a half. And again, get our nice curve. So now looking at our transformations for exponential and logarithmic, we can see they're very similar to our transformations from before, right? We still have an A, a B, an H, and a K, and they do the same things as they did before. So to review, A is a vertical stretch or compress. B is going to be our horizontal stretch or compress. H is going to be our horizontal translation. And K will be our vertical translation. All right, so for example 2, you're going to take the parent functions that we created on our first page and use them to write our transformations. So like before, we're going to make a equation for a transformation. Let's go ahead and start with y. So y is our vertical, so that's going to be a and k. In this case, our a is 1, and our k is minus 3. So we can say 1y minus 3. Then our x is horizontal, so that's going to be b and h. And here again we can say, and this is tough to see, b is the value in front of x. In this case, it's going to be 1 again. And then that plus 1 right there is our h. And one thing we need to remember for our x values, b, we need to use the reciprocal, and h, we need to do opposite sign. So since that's a plus 1, our h is going to be minus 1. So for our equation, it's going to be, well, the reciprocal of 1 is 1, so that doesn't change. So it's going to be 1x minus 1. And then using the parent function from before, we'll plug in our values. So minus 2 minus 1. And then minus 1 minus 1. 0 minus 1. 1 minus 1. And 2 minus 1. And then same thing for our y values. So a quarter, or 0.25 minus 3. 2.75. Negative 2.75. A half minus 3, negative 2.5. Describing the transformations, that's just really write in words what happened. So our vertical is -3, so that's going to be down 3. Our horizontal is +1. And we're going to think opposite, so that's going to be left 1. Or we can say it's a translation. Three units down and 1 unit left. All right, so we're going to do the log in the same way. We identify our a, b, h, and k, and then create an equation. Use the parent function that we've already made to find our new values. So for y, the y values stay the same. So it's going to be -2y plus 1. And then for x, so when there's no value written, we say it's 1. And then we need to use the opposite sign. So reciprocal of 1 again is 1. It's going to be 1x. Opposite, so we say +2. Plugging in our values from our parent. And again, I'm just using the parent that we made last time and plugging in the values. So for example, this was 2 times -2 plus 1. And this was 1/4 plus 2. So description of the transformation. We also have to talk about that negative. So that gives us a reflection. Over the x-axis. Then we have a couple translations. So 1 unit up, 2 units right. And this time we also have a vertical stretch. By a factor of 2. Okay, last one. So for our base E, again, y is our vertical, so a and k. It's going to be 3y minus 4. So for x, again, number's not written, it's 1. And then we need to do opposite sign. So we're going to have 1x minus 2. Right, so for our x values, minus 2, minus 2, minus 1, minus 2, 0, minus 2, 1 minus 2, and 2 minus 2. Now for your y values, I would suggest using the exact and finding a new approximation. So for example, I would say in a calculator do 3e to the minus 2 minus 4, etc. I like to use Desmos, but you should be able to do that in any calculator. So let me show you in Desmos. This is 3 times e to the minus 2 minus 4. And the nice thing about Desmos is once you have this set up, it's really easy to do minus 1, 0, 1, and 2. Now, let's put in those values. And again, I'm going to round to the nearest tenth. And description of our transformations. So we have 4 units down, 2 units left. And we also have a vertical stretch by a factor of 3. All right, all that's left is to graph each. So I'm just going to plug in the points. That's minus 3, minus 2.75, minus 2, minus 2.5, minus 1, minus 2, 0, minus 1, and 1, 1. So for the next one, we have 2.25 and 5. 2.5 and 3. 3, 1, 4, minus 1, 6, minus 3. Last one. And again, anytime we're working with E and we have values like 0.6, 0.9, close is good enough when we're graphing. So minus 4 and minus 3.6, it's really close to 3.5. Minus 3, minus 2.9, it's really close to 3. Minus 2, minus 1, minus 1 and 4.2, so just a little bit more than 4. And 0, 18.2, a little bit more than 18. All right, for the last example, we want to match the graphs to the given equations. A couple ways we can think of this. First thing I would say is identify what your H and K are doing. So for example, minus 3 at the end, that means we're moving down 3. A minus 3 on the inside, that means we're moving to the right 3. And then we can do that for each one. So minus 3 on the outside, again, that's moving down 3, but now it's plus on the inside, so that's moving left 3. Plus on the outside, so that's going to be up 3. Minus on the inside, that's right 3. Again, up 3, and this one's left 3. We have a base of 2, so we can still use our parent function from before. So quick look at our parent function. So this is our y equals 2 to the x. Now we can just reason it out just by looking at it and say, well, if I took this and I moved to the right 3 and down 3, so right 3 and down 3, looks like it would probably be this one. The other way to do it is to pick a specific point. So for example, the parent has the point 0, 1. If I move that point right 3 and down 3, so 1, 2, 3, 1, 2, 3. My new point should be 3 minus 2. And we can definitely see that here. So if I started at 1 and I went over 3 and down 3. So this one must be A. So let's take a look at the others and see what happens. So for this, I definitely know I'm going to need to go up. And since all of the ups are by 3, let's see what happens if I go up 3. So 1, 2, 3. Now from here to get to my graph, I have to go to the right. And again, all of the movements to the right are 3. 1, 2, 3. So up and to the right must be C. And again, I'll start at 1 and 1, 2, 3, since all my up movements are 3. And then to get 1, 2, 3. So up and to the left. So that must be D. And then the last one is definitely going to be B. That's all that's left. But let's see if it matches. So B is down 3, left 3. So if I start at 1 and go down 1, 2, 3, and left 1, 2, 3. Yep, that works. Okay, so I'm going to give you a reminder for our first practice problem before I let you go. So looking at practice problem 1, we want to create the table and graph the parent function for y equals 3 to the x, and then make a transform table. Because this has a base 3, we cannot use the parent function we made. The parent function we made at the beginning was base 2, so that will not work. So we have to make a new parent function for base 3, and then use this to find our transformation.